I tried watching the first episode and somebody kicked the dog and I immediately said no.
Oh yeah, that's a standard right?
What? Oh, yeah.
It's a lot worse than that.
I've heard. That's why I haven't watched JoJo's Bizarre Adventure.
Just made me think, because it sounds like your family is similar naming.
Oh, my dad's side of the family. So my brothers are the fly third. My dad's name is just the second fly. My father's name is Fly, my aunt's name is Cynthia and Cheryl. They all have the middle initial as well.
16.
That's hilarious. I don't think my wife gets any at all.
There's something there.
Just in case. Extra one. There you go. I believe we have 22 students enrolled here. 22. Hey, how's it going? Here you go. Anywhere you like. All right, so I just passed out the schedule. Coming now is isometric graph paper, which is basically 3D graph paper. But you take 4 each, okay? Each of you get 4 for now, all right? So take 4, pass. Yes?
So the page numbers and stuff that you give, I'm assuming that's using the digital book. I have a physical copy of the book.
Yeah.
Will those page numbers translate?
It's really for the book. The page number is more for the book, but the section in the ebook is all you need to do the homework, right? You don't need the page number.
Okay.
You just go to the ebook, go to that section, and do those problems.
Would that homework be?
They're exactly the same.
Okay.
Yep, the problems are exactly the
I
same.
got this book for Cal 1, and it's amazing.
It's still there. Yep.
But I was just wondering if I needed, if this was.
Nope, it matches up. It matches exactly. Yeah, right? All right, shall we begin? All right, I'm pretty sure you know where you are. Cal 3, right?
I hope so.
So my name's Robert. Almost forgot my name there for a second. Robert Di Giovanni. I recognize some faces, and I have new faces as well, faces I've seen down in the office with Mr. Roy. So this is me. And let's see, I don't want to talk too much about myself, but I've been here for a long time. This is 20 years this year. It's actually my 20th year. It's crazy. Yeah, it's been forever. I finished grad school. I was like, you know what? I'm going to go get a real job. But I was already teaching here. I was like, I'm going to go get a real job. But let me take a year off and go just teach for a while and just like chill. And that was 20 years ago. So yeah, I love this. And I love the calculus sequence. This is Cal 3, right? So this is the end of the road as far as calculus. Can I borrow your book, Hunter? So our class is based upon this textbook, right? The Essential Calculus by Stewart. We've been using this book for like 10 years or so. And Cal 1, 2, and 3 are all contained in this book, right? My goal is to finish this book this semester, all right? That's the goal, is to get through all of this. So then you can put it on your shelf. And is there more? You take more. Did they get some? You got some? All right. I sent out the orientation video. Were there any questions? Everybody watch it? Everybody was able to see it? No? Did you? No? Okay, but you have access to it? Yes. Okay, make sure you watch it because I go through all basically how the class is laid out, right? No one had questions? Okay, so if I give you a quiz right now over the like evaluation of the course, how it's set up? No, I'm not going to give you a quiz. So how's your grade determined in this class? Okay, what type of exams? Take-home exams and a midterm and a final. And that's pretty much it, right? So you have 8 exams, 8 or 9 exams that I'll give you as take-home exams. They come about every 2 weeks. You'll get one. And then you only have to do how many of them? You only have to do 6 of the 8 or 9 that I give you. So you can do all of them and I'll just drop your lowest 2. Or you get to a point where you have, other classes that you're panicking, right? And you're like, okay, I don't have time for that exam, right? They are not all equally difficult. Some of them are easy. Some of these take-homes are easier than others, right? I'm not going to tell you which ones, but you might be like, man, I shouldn't have skipped that one. It was easier than this one. But that's, that's the trade-off. All right, so I have your first one now, right?
Oh boy.
This is your first exam. It's not due till February 8th, which is actually a couple of weeks from now. It says it all on here. Actually, give me a copy. I'll just come get one here. Yeah, thank you. So I'll let this get around and we can talk about it. What else? Let that exam get around. It's only 6 problems. I don't have a PDF version. I mean, I can get you one, but I'm going to do paper and good old-fashioned style. I may do PDF. I don't like this floating around electronically.
Understandable.
Yeah. It's almost there. All right, so let's talk about this first exam quickly. Everyone got it? So I call this mini exam 1, right? Take home spring 2023, due February 8th, beginning of class. You walk in, you put your papers up here, right? Stapled, neat, in order, number 1 followed by number 2. If you write in pen, it better be perfect, like no scribbly scratches, right? Needs to be nice and neat. I know some of you do stuff on tablets. I understand, that's great. You still would need to print it out and give me a hard copy, all right? Let's see, what do I say on this first one? Because not all mini exams are the same. I say here, you may work with classmates on this exam. So I have not given you any restrictions in terms of like, you can only work in pairs or groups of 3 or groups of 4. You can talk to each other about this exam, all right? Because it's the first one, right? And you're not allowed to get outside help. So if I walk by and I see you at the lab or at the UTSA library or gyms or somewhere, and you're sitting there with people that aren't in this class and you're talking about the exam, what? You're gone. You're out of the class. Okay? I'm serious about this. All right? So if you're in the tutoring lab, it needs to be only you and the people in the class. It can't be other people discussing it with you. All right? Clear? Okay. All right. We'll have to work things out for this first exam as far as my expectations in terms of neatness. Are you showing all the work I want to see? Just assume I want to see everything. Notice it says here that I want you, all these problems should be done using concepts from 10.1 through 10.5. Chapter 10, section 1 through chapter 10, section 5. That's how these problems should be solved. Now, if you use some other method, then you're going to be deviating from that a little bit, and you should probably check with me first. Does that make sense? Because there are some other ways to solve some of these problems, and I would hate for you to do it that way, not using the concepts from this chapter, and then I grade it and I take off because of that. Because I explicitly say you should use the concepts. So talk with me. No calculators or computers for this exam, which means that everything here should be able to be done by hand. So if you have to solve an equation, it should be done by hand. Yes?
For the pictures of the actual, I know you have a picture of the finished diagram. Do we have to do that by hand?
picture, well, this is not going to require any pictures. Like, you don't have to submit an answer that has some graph or anything like that for this exam. Yeah, but in the future, I may say, yeah, if you have to graph something, you can go to like Desmos, graph it, clip it, print it, include it in your work, right? Is that what you're kind of referring to, or?
Yes, but also I thought instead of using Desmos and stuff like that, we were going to use the software that you use.
Oh, no, Wolfram Alpha, no, the software, that was just so you can use the note, like you can like play with my notes the way I'm going to play with them up here. That's all that was for. Yeah. Yeah, this is called Mathematica, Wolfram. So when I'm like spinning things around in three-dimensional space, you have the ability. Has anyone tried it yet? Has anyone downloaded those files? Does it work?
Yeah.
Okay. Some of my files might be buggy. I mean, my code for those has not changed in a long time. I'm wondering, can y'all see my code in there or no? Have y'all tried? Because normally, I don't want to go too far off track. We don't have time for this. But normally, like, there's a cell here that you can open, and you can actually see the code that I wrote for that thing to do what it's doing. I don't know if you have the ability to see the code or not. I don't know if you can. If you can, you can. If you can't, you can't. But unless you have the full-blown version of the program. Yes?
Are we going to go over the concepts leading up to this mini exam, or is this something that we have to read?
Oh, no, okay, good question. So the reason this is due February 8 is because we haven't talked, I have not covered what we need in order to do this exam. Like, in theory, you shouldn't be able to do this yet, in theory, but as I proceed through the class, by the time we finish 10.5, you should be able to handle this.
So
Good question.
probably not going to be good to take this and do it immediately after class.
Oh yeah, you're not going to do it, but you might walk away from today's class with something that kind of says, you know what, I might be able to use that for number 1 or number 2, or you can start to put the pieces together. And this way you kind of know what you're looking for. I will say these problems are nothing like what you're going to see in the book, though. Like, you're not going to go Google this problem and find it, and you know what I mean? So it's going to be different than, a lot of the problems will be different than the textbook problems. Yes?
So when we finish like a take-home exam, are we gonna get like some sort of breakdown on like what we did through the exam, like giving back the exam?
Oh yeah, I will grade it, and then I will give it back, and then you'll see what points I took off. You'll get feedback. Might take me a little while, but yeah.
We do like a
Hey, what?
can you take a look to see if maybe anything's right?
You can come to me. You may come to me for help or call me, right? So if you come to me and you ask me, hey, did I do this right? I may or may not. It just, I'm not going to grade your test before you hand it in and be like, yep, it's all good. But if you're like way off, I'm going to put you back on, try and get you back on track. If you look like you're doing okay, yeah, good job, right? What else?
And then last one, sorry about that. After we finish this first exam on February 8th, are we expected to get another exam? Like,
You'll probably get the next exam the day you turn this one in.
so that should be kind
Yeah,
of like,
it's just going to be this never-ending stream of exams. Yeah, yeah. Yes?
So these are obviously published in the book, but I'm assuming we're going to go are you going to give us like more handouts that you create for us?
Say that again.
So for the homework that we're going to get, is it just going to be the book problems, or are you ever going to give us handouts that are just of your problems that you make?
The only homework problems you have are the ones that are on the schedule. That's it. And so the way I think about this is like, you first do this, all right? This is your number 1 priority before you start the mini exam. Now, even though I'm saying that, I know a lot of you are going to go right after the mini exam because it's part of your grade and this isn't part of your grade. But the idea is that once you've done this, you've established the foundation you need to be able to do the mini exam problems. And so if you're not making the connections to do that exam, it's probably because you haven't really gone through this enough. And I'll know if you come ask me and I'll be like, well, did you do your homework? Because the homework would lead you into this. Like, you know what I mean? So, but other than that, there's no other like handout or problems that I give you. All right. I have a sign-in sheet, which I'll probably forget to hand out. every semester, probably the only time I'm going to do it. I'll try and remember. So it has your name, has today's date, a little tiny box initial in there, and I'll try and keep track of attendance. All right, what have y'all heard about Cal 3? Do we need to should we talk about this class before we just dive in? Like what it's about? Have y'all had any discussions with anyone about it?
I've been told it's like Calculus 1, but way harder.
Cal 1, but harder, okay.
I had a classmate in FEQ show me some, the integral, nested integrals.
Okay. Yeah, so basically, have you heard this class harder, easier than Cal 2? Have y'all heard?
I've heard it's easier, but
Easier?
A lot more memorization.
More memorization, yeah. I think I mentioned in the orientation video, we just have a tremendous amount of ground to cover. We have so much ground to cover. And that, along with there's just so many formulas and distinguishing things from one another, that it is just like a lot of information. But you have all the tools already. If you're here, if you successfully got through Cal 1 and Cal 2, you know how to differentiate, you know how to integrate, you know some things about series. Good news, series will not appear in this class. So you're kind of safe there a little bit. But yeah, all we're going to do is take calculus, right? Cal 1 and Cal 2, which always restricted us to a flat sheet of paper and a function of a single variable, right? So we always said, let's just do a quick little glance back. Cal 1, right? Cal 1, what we did is we took a function, main idea, take a point, find the slope of that tangent line, right? Slope of tangent line has to do with the derivative, right? That's Cal 1. Cal 2, take the same function, define it on some interval AB. You know, we can find the area under that. We can find the length of that arc. We can revolve that around the x-axis, get a volume of a solid of revolution, right? All these sorts of different things, but really it's like slope of tangent line, area under curve. But notice our functions are flat on a flat sheet of paper, right? We refer to these as functions of a single variable, right? This right here is y equals some function of x. Well, in the real world, right, we want calculus to be practical, right? In the real world, we're living in three-dimensional space, right? So we'd like our functions to live in three-dimensional space as well, right? So we need to move all these ideas of calculus out into a higher dimension and then talk again about what it means to take the derivative and then what does it mean to integrate and what geometrically does it mean. So think about this. Think about this. Imagine this sheet kind of waving around, right? It's three-dimensional, it's just this sheet in the air, right? Freeze it, there it is, right? If I were to stand at a point on that, could you talk about the slope of a tangent line? What do you think?
I mean, I imagine, yeah.
At that point, another way to think about it is imagine, remember this thing goes up and down, right? Kind of undulates. If I were to take a ball, a little ball, put it on that point and let it go, it's going to go somewhere, right?
Yeah.
It's going to go in the direction of, what? What direction should it go? Where the slope is down and the steepest, right? Yeah. So you can almost think about a basketball or a globe or whatever. If you drop a ball in the North Pole, just put a ball in the North Pole, which way is it going to go? It should go nowhere, right? Should go nowhere. It should just sit there. If it's a perfect theoretical ball, right? It should just sit there. But if you make it more, I don't know, it's just kind of, let's go back to that. It should go somewhere, right? But tangent, in terms of a tangent line, we don't have one tangent line.
It'd be a tangent plane.
We'd have a tangent plane, exactly. So we could say that if you're standing on that sheet, if you go to a certain direction, right, you should have some steepness there. But if you change your direction, that might change as well. Yes? So we have this thing called the directional derivative, which is different than the normal derivative. So we get into that, and then what we do is we say, okay, if this is three-dimensional, then can you imagine like we did with the with the interval, right, where we did this and dropped down and found the area. Can you imagine looking below that sheet, dropping it down to the ground and finding the volume of that? Right? I mean, we could do that, yes. I mean, like, it seems like that should be something we could do. Yeah?
Yeah.
So we'll do that. That's where the nested, you said nested integrals,
Yeah,
double,
what's the
triple
proper-
integrals,
triple, yeah.
double and triple integrals, so we do that. And then we go and we have to deal with vectors and a bunch of other stuff. So anyways, we will unveil this as we go. I want to get into the material though. So we're going to start with the 3D coordinate system. Oh, I'm recording these classes, right? Did I mention that in the orientation? I don't know if I did. I'm recording this. This will be posted on YouTube later, barring any technical glitches. I forget to unmute my microphone. I forget to hit record. These things happen, right? My SD card gets corrupted somehow, right? So don't depend on it, but hopefully it'll be there as a resource for you. So as you're sitting here, you don't have to sit here and copy all these notes down. These are all available to you, right? It's more of you understanding, asking questions, making sure you get the concepts, right? All right, so 3D coordinate system. Right away, we're going to get into three-dimensional space. And the first note here takes us back to one-dimensional space.
Nice.
So if you sit here and say, all right, X is, imagine we live in what's called R1. That's the way we say one-dimensional space. Y'all have seen R before, right? We've usually said that means all real numbers, right?
Yeah.
But I want you to think of it more of that representing just the number line. Okay, our traditional like x-axis, the number line. Okay? That's R1, that's one-dimensional space. If I'm forcing you to live in one-dimensional space, and then I say x is equal to 2, then we can visualize x is equal to 2 as a point on the number line, right? So there's nothing, no surprise you're just sitting there. I'm in Cal 3, I know this, but so if I say x is equal to some number, it's just some point on that number line, right? Wow, that's really laggy. Why is that so laggy? I don't know.
The whole thing just
Okay.
is laggy.
There we go. I think it caught up. Okay, so in one-dimensional space, x equals 2 is a point, right? This is a point on, we'll say, the x-axis. The important thing, and this is something that I guess we don't talk a lot about when we're in college algebra, pre-cal, cal 1, cal 2, is that we need to be aware of where we live, okay? Right now we live in R1, so x equals 2 is just a point on the x-axis. Now, what if we now go to R2, two-dimensional space? So now what we do is we take the number line we used to have, right? And we make a copy of it, and we draw it orthogonal or perpendicular to the x-axis we just had. So we have two axes, right? The x-y plane is what we call that, right? The xy plane. And now if I want to talk about something here, right? If I want to talk about something that lives here in R2, well, if I want to refer to a point somewhere in here, then I have to write it as, what do we call this thing? An ordered pair, right? An ordered pair. It's a pair of numbers, and the order matters, right? The first coordinate of that point is the x value. The second coordinate y is the y value, right? So xy. We're comfortable here? Yes?
Yep.
Okay. So now let me ask you, you're still living in R2, all right? You're still living in R2. If you're in R2, what does x equal 2 look like?
A line.
Okay, what kind of line?
Value of y, x is equal to 2.
X is equal to 2, so it's a line. It's vertical line. This right here now represents not a point on the x-axis. This is all points, right? This is all points in the two-dimensional space, right? All points such that, I'm going to write ST to stand for such that, right? It's all points in two-dimensional space such that the x coordinate is 2, right? And your y coordinate is whatever you want it to be. So I'm going to leave it as y, and we call this a free variable. All right, so you've got a free variable here. That's what x equals 2 looks like. It's a vertical line. If you draw it, it would just be like that. Now, what if I wrote y equals 2?
It'd be a horizontal.
Horizontal. It just basically what happens is that you have now your y is 2, right, and your x is free. So it matters, right, what space you're in? What space you're in dictates what you're looking at visually. Any questions? All right. Okay, these animations, I don't go through every one of these here. You can just like go and play with these. Like, it's just more, I did these more for fun. Now, let's talk about, I already talked about that. Let's talk about other lines that live in two-dimensional space. So those aren't the only lines that live in 2D, right? You have those, that x equals a number is a vertical line, y equals a number is a horizontal line, but you can have all sorts of relationships like this one. If your x is equal to your y, then you have the diagonal, don't you? But as an ordered pair, every point on this line, if that's our relationship, every point on that line should be what as an ordered pair? The x and the y should be the same, shouldn't they?
Yeah.
Right? So it's all ordered pairs where the x and the y coordinates are equal to one another. Yeah? We could have a line like this. Y equals 3x. So it just has a steeper slope. That's all. Right? Just a steeper slope. There's an infinite number of lines, aren't there? Okay. Negative slope. All right. None of that should be new to you. That should all be, okay, great. What we're interested in is R3. Okay, so this is our first dive into R3. So if R1 gave us just a single point, right, on a number line, R2 gave us two axes, right, where you had ordered pairs, then R3 should be three axes, right, three number lines put together, which would look like that, right? We have the x and y that we had before. I'm trying to do it like that. That's the x and y we had before, right? But now we have this new number line, and the only way we can go with it is out towards us, right? Or into the board. And that's going to be our z axis. So we have x, y, and z. And if I take a point here, right? If I take some point, let me just move this around. See, if I take some point in three-dimensional space like that, then this point is going to require three pieces of information, right?
Yeah.
It's going to be the x, the y, and then the z value. So, okay, hold on. All right. X, y, z, right? Is it going to be required? We call this an ordered, what do you think?
Trio?
Triple. Ordered triple. Ordered triple. It's an ordered triple. The x coordinate, the y coordinate, z coordinate. Now I gave you a piece of paper to help you with this, because drawing in three-dimensional space, drawing 3 dimensions on a flat sheet of paper is not something that comes naturally right away for us. So this is called isometric paper or three-dimensional graphing paper, and it just helps you to graph something in three-dimensional space. So I would like to take just a moment to do one with you. So I would like us to take plot on one of your papers. Let's plot 2, 3, 4. Let's plot that point. All right, you see the x, the y, and the z, yeah? When I write down x, y, z, everyone pay attention. When I write x, y, z on a grid like this, the x is always going to be, for this class, is always going to be the positive direction of x. The y will always be the positive direction of y, and the z will be the positive direction of z, right? That way there's no confusion as to which way is positive and which way is negative. Whichever side the letter lands on is the positive direction. So if you want, you could add to this, you know, x positive, y positive, z positive. All right, so let's start out. I'm going to start out with my x coordinate is 2, right? So all I'm going to do is start at the origin, right? And I need to move out this axis 2 units. So you see all these lines like this? That's what I'm going to count. So 1, 2, that's where I am. And then I need to go, y is 3. So you can do this a couple of different ways. You could go on your y-axis, go out to 3, right, which would put you here. Or you could go from the point that you're already at and follow it 3 units out this way. But you have to be running parallel to the y-axis when you do this. So I would go 1, 2, 3. That's where I am now. You'll see it's like we're sliding across the ground. Oh yeah, by the way, I have 3-dimensional space here. Oh shit. Yeah, that's it right there. X positive, y positive, z positive. So what we've done here is we've come out 2, right, on the x. We're coming over 1, 2, 3 on the y. We're about to go 1, 2, 3, 4 up on the z, right? So from here, 4 units up. So I'm counting these, 1, 2, 3, 4. So 1, 2, 3, 4, right there. That's the point. That's where we are. Yes?
Would it help like draw lines? Like
Yeah, so maybe what could help us see this is to box it. If you draw a box, it might help you see where it is. So like if you do something like this, see I'm drawing a little box. That's the box that's on the ground. And then if I go straight up, does that help you see it a little bit better? Or maybe you box the whole thing. Go up 1, 2, 3, 4 here. Come over 1, 2 like we did on the X. Connect over. I mean, you got to go play with this, all right? You've got to get comfortable in this space. Y'all see it?
Yep.
So that's how we plot a point, right? That's how we plot a point in 3-dimensional space. No one has a question?
I accidentally made it to -3, 4 on my paper.
To -3? Yeah.
I went the wrong direction on the y.
Yeah, so in my little animation that I have in the class notes, if you go play with this at home or something, as you move the point around, it draws the box for you. So it helps you see, where it is.